So everyone, welcome back. In this video we want to basically learn how to evaluate exponential functions. And basically when we were talking about the definition of exponential functions, we said that an exponential function is any function in the form f of x, is equal to a times b raised to the power x, and here we said that b is any positive real number, so b belongs to R, real number, and b has to be greater than 0, it has to be a positive number, and also b is not supposed to be equal to 1. And the reason why that is the case is that basically if b is if b is a negative number, if b is less than 0, then for example let's say b is equal to -9. And so if you have a number, if you have a function, for example, if you have a function f of x is equal to, let's say my a is equal to 1 and b is equal to -9 raised to the power x, here f of half is equal to -9 raised to the power half. And this is basically, I'm sorry, not negative half, but half raised to the power half raised to the power 1/2. And this is basically the second root of -9. The second root of -9. Or you can even write, you can also write it as this, the principal root of -9. And this is not going to be a real number. This is going to be an imaginary number. So basically that's why we define b as not being less than 0. And moreover, if b is equal to 1, so if your b is equal to 1, then let's say your b is equal to, okay, so let's say your b is equal to 1. Let's say you have a function like f of x is equal to 1 raised to the power x. Now this function, whatever value you choose for x, for example you calculate f of 1, this becomes 1 raised to the power 1, which is equal to 1. F of 2 becomes 1 raised to the power 2, which is equal to 1. And f of 1000, which becomes 1 raised to the power 1000, which is equal to 1. So then this becomes basically your f of x practically becomes f of x is equal to 1, which is just a horizontal straight line, is a constant function, a horizontal line that will never change over time. So that basically means that this function, this is your function, and this is f of x is equal to 1 raised to the power x. So this basically does not do anything for me, so basically b cannot be equal to 1. So that's the reason why we defined exponential functions like that. And now let's get to evaluating some exponential functions. And if you have an exponential function, for example f of x is equal to b raised to the power x, I don't know what happened here. If you have f of x is equal to b raised to the power x, to evaluate the function it's very easy. You basically substitute x with any value of x, and then you can evaluate the function. For example, your f of x is equal to 2 raised to the power x. So then here, for example, your f of 3 is equal to 2 raised to cube, or 2 raised to the power 3, which is equal to 8. And also you basically know that you have to follow the order of operation and things like that. For example, as far as the order of operation is concerned, you have f of x is equal to, for example, 30 times 2 raised to the power x. So this is your a, this is your b, and this is your exponent. So here, for example, your f of 3 is equal to 30 times 2 raised to the power 3. And here first, you cannot multiply before you raise 2 to the third power. So you have to write this as 30 times 2 cubed, which is equal to 8. And then this is equal to 240. So that's basically how you follow the order of operations. And also we have another example here. If your f of x is equal to 5 times 3 raised to the power x plus 1, so you want to evaluate f of 2 without a calculator. So let's see if we can do it. So it is equal to 5 times 3 raised to the power 2 plus 1, which is equal to 5 times 3 raised to the power 3, which is equal to 5 times 9, which is equal to 45. Oh, I'm sorry. No, I made a horrible mistake here. Is it? Oh, yes, I'm sorry. So this is 5 times 27, and 5 times 27 is 5 times 20 is 5 times 20 is 100, and 5 times 7 is 35, so it's 135. 135. I'm sorry, I almost made a mistake. So another example that we can have is the try number 2 on page 467, which is let f of x be equal to 8 times 1.2 raised to the power x minus 5. And we want to evaluate f of 3, and we are allowed to use a calculator. And we want to round to 4 decimal places. So first of all, you have to substitute 3 for x. So here you have 8 times 1.2 raised to the power 3 minus 5. So 3 minus 5, which is equal to 8 times 1.2 raised to the power negative 2. And this is equal to 8 times 1 over 1.2 raised to the power 2. And this is what? Let me see. 1.2 raised to the power 2 is 1.2. No, 1.2 raised to the power 2 is equal to 1.44. So this is 8 times 1 over 1.44. And this is equal to, basically, this is equal to 8 over 1.44. And what is that? So 8 divided by 1.44, which is equal to 5.555, and this has been, of course, rounded, so 5.5556. So this is approximately equal to 5.5556. So that's basically this function evaluated. So in the next video we are going to define exponential growth, and then after that we have growth models, finding equations of exponential functions, and we have a lot of interesting material to cover after these videos. Basically, I personally find these very interesting. You get to play with your logic, and of course they are I mean, these kinds of functions are used very widely in the world. Be it your bank account, you want to take a loan, you want to do anything in the world, of course you need all of these functions. So I'll see you in the next video.